And this directly brings me to the next slides. Shortly want to give you an overview about the webinar series we already scheduled. So today we, as I said, want to talk about Meet COMPREDICT, the virtual sensor company, which means that we want to give you an overview about our company. We will talk about what is a virtual sensor, and we will define the application areas of virtual sensors. In our next webinar, in the middle of June, we will do a deep dive into a concrete vehicle R&D use case, the wheel force transducer. And we will tell you how to virtualize wheel force transducers with virtual sensors. So how to use it, use case examples, and also we will talk about the performance evaluation of our virtual sensor. And last but not least, our third webinar, which will take place at the end of June, where we will do a deep dive into COMPREDICT's virtual sensor platform, our SaaS product, which we launched at the beginning of this year. We will talk about the benefits of the VSP, we'll give you a live demonstration, and of course, we'll also talk about the real customer use case on the platform. And with having said this, I would say, let's start with today's content and start with the company overview.
All right, yeah. Hi, everyone from my side as well. So yeah, few facts about the company. First things first. COMPREDICT was founded in 2016 as an academic spin-off from the Technical University of Darmstadt. So both our founders successfully acquired their PhD there at the Institute of Mechatronic Systems. And one of the two dissertations served as the initial idea of founding COMPREDICT. Our headquarters is still located in the heart of Darmstadt, near Frankfurt. However, our team is spread all over Europe. We will come to that in a minute as well. From a customer perspective, we focus on the automotive OEM on the one hand side and on the tier one supplier on the other. The reason for this is quite simple, as these parties have the data for our virtual sensors available or accessible in order to perform quite well. And as of today, we have successfully closed 3 financing rounds, and we are backed by a strong mix of, on the one hand side, automotive-centric, and on the other hand side, financial investors. And we are very proud of that. There's a very healthy interest in our upcoming next financing round, which we will announce in a couple of weeks. So stay tuned for this as well. What is very important for us, our most valuable asset, I would say, is our passionate team behind the virtual sensors. What makes this team so unique is that it combines 2 expertise or knowledge bases, so to say. So on the one hand side, we have experts in data science and machine learning, and on the other hand side, automotive domain expertise. Right now, we are about 40 people from all over the world, which is great to have a team with such a diverse background. But especially if we are talking about our upcoming financing round, the team is about to grow. And therefore, Stefan?
Yeah, we all invite you to scan the QR code, of course, if you're now having also maybe in mind to join COMPREDICT. We still have 5 open positions right now, and of course, there will be more in the future, also with the next financing round ahead. So feel free to scan QR code and visit the website. So I would say now you know the company a little bit, you also know the team, and of course you all want to know about the technology. This is why you are here today. And yeah, first of all, a little bit of introduction, I would say, before we are coming to the definition of what a virtual sensor is. Maybe to give you some background also from the industry point of view. I mean, we all know software is redefining the automotive industry, but what does it mean? It really means that we are shifting from domain architecture to a zonal architecture. And we are also talking about decoupling software from hardware. So we are shifting from traditional vehicles to software-defined vehicles. And this means really that we have faster and continuous development capabilities, that we have advanced user experiences and functionalities, and it's all about connectivity, enabling digital services, digital features, and building really smart devices. And of course, from an OEM perspective, there's a lot of potential for additional revenue. And all these trends, or this major trend shifting from traditional vehicles to SDVs, is a strong tailwind for virtual sensors. because we can use the over-the-air updates, we can use the adaptabilities, we can use the higher computing power in the vehicles to really provide valuable data insights with our virtual sensors. And how this works and what a virtual sensor is, Daniel will talk now about it.
All right, so first things first, the most important thing that you need to take out of this webinar, a virtual sensor is an intelligent algorithm. So it's a software piece, and COMPREDICT is therefore a pure software company. We're not doing any hardware related stuff. The entire idea of virtual sensors starts with data and information that is already available or accessible in vehicles due to the wide-ranging set of hardware sensors these vehicles have, responsible for the core functionality. So you might think of sensors for the wheel speed, the steering angle, the engine torque, and so on and so on. So again, it's just the core functionality that the vehicle is actually performing how it should. And these signals serve as input signals for our virtual sensors. What is unique that we are incorporating these input signals and feed it with not only incorporating AI and machine learning expertise, but also enhance it with physical knowledge from the vehicle dynamics and durability engineering space. So basically, this is a mix of these two domains, which ensures the plausibility of the results of the virtual sensors are all set all the time in the entire vehicle lifecycle. The outputs of our virtual sensors can be quite diverse as well. So it can, on the one hand side, replace actual hardware sensors. It can also serve for health and usage monitoring reasons, or AKA predictive maintenance. We will come to that in a minute as well. Or we can also virtualize additional equipment. But the nice thing is that we are utilizing the virtual sensor for the entire vehicle lifecycle, and Stefan is going to give us a little better idea on this topic.
Exactly. Because these diverse benefits, of course, also reflect the value we are creating for OEMs. We are not creating value for only one department or one target group within an OEM. We are really creating value across the entire OEM organization. But I will give you some examples what really we are not creating value for only one department or one target group within an OEM. We are really creating value across the entire OEM organization. But I will give you some examples what really is, I would say, the value we deliver. On the left-hand side, you see topics like vehicle engineering, manufacturing, warranty. And there we are really talking about virtual sensors we have in our portfolio that makes it able for vehicle engineers, durability engineers, test engineers to really leverage the R&D equipment you have so far with respect to hardware sensors. Also, we can make every series vehicle as smart as your development vehicles, but more on that later. Coming to the manufacturing point, this is due to the fact that we can replace hardware sensors completely within a vehicle by software and AI-based models. And of course, as software is much easier to get and much easier to replace, we also improve supply chains resilience for the vehicles. And what we are also able to do is like identify really quickly the root causes of errors within a vehicle, which means that OEM people or the target audience has more time and can quicker react to costly warranty cases. And on the right-hand side, you see the other, I would say, target group and value we deliver within an OEM. It's all about customer relationship. It's all about digital business, after sales, where we're really talking about new customer experience, new digital functions, and also new data that vehicles can deliver. And here we are talking about health and usage monitoring cases where we are able to deliver with our virtual sensors outputs that are really valuable to use them, for example, for digital twins, also for predictive maintenance, recommendation for maintenance in front of the customers. And last but not least, you can also see like a car health certificate. This is, for example, something we showcased last year at VivaTech together with our partner or as part of the Software Republic. Where they launched a human first vision concept car. And coming all in all, or generally about virtual sensors, talking about it, we are able to deploy virtual sensors either via cloud or directly into the vehicle. And this, of course, depends on the computing power we have in the vehicles, but also on the use case and the respective virtual sensor. And also important to know is that our virtual sensor technology works for any kind of vehicles. This means that we are not talking about only passenger vehicles. We are also talking about trucks. We are talking about buses and also other vehicles that can deliver the data we need. And on the right bottom, you see the application areas where we also have various from. And this is exactly what we want to talk next about.
Yes, because basically you can divide the application areas of virtual sensors in three pillars, as we call them. The first one would be the actual hardware sensor replacement or software redundancy, especially when you think of safety critical applications such as ADAS systems, for example. The second would be the whole wide world for predictive maintenance solutions for wear components. So basically we have virtual sensors for all kinds of wear components like tires, brakes, vehicle mass, and many more. And the last topic, or third, would be the virtualization of additional measurement equipment, which is normally used in R&D scenarios by OEMs for the dimensioning of components, for example. In other words, we heard that term as well. We making series production vehicles as smart as development vehicles. And Stefan, maybe you can start to give us a broad idea about the first two topics.
Yeah, of course. So first one, hardware sensor replacement, one of my favorite topics because it's so valuable for our customers. And this is really about saving costs because once virtualized the sensor, the hardware sensor you have, we can completely get rid of the hardware sensor. And as you can imagine, I guess having like software instead of hardware in all the series production vehicles on the road, this can result in massive cost savings, I would say. On the other hand, besides hardware sensor replacement, of course, if you still want to stick to maybe also one hardware sensor, you can also use the virtual sensor as some kind of software redundancy to back up your hardware sensor and to significantly increase safety and reliability. To maybe give you an example for this pillar, a good one is, I guess, tire pressure, because everyone can imagine in today's vehicles where we normally have like 4 tire pressure sensors, so 1 per each wheel. We are able to virtualize these tire pressure sensors and get at least rid of 3 of them. And of course, this is massive cost savings when we're really talking about series production vehicles. And most important, I would say, without losing any accuracy from the sensor. Coming to our second pillar, the health and usage monitoring. There, I would say this is explicitly interesting for the ones who joined maybe from Aftersales and also digital business, because these powerful virtual sensors, of course, really enable OEMs to deliver predictive maintenance solutions. Because, for example, like tire wear or brake wear, we are not only able to continuously monitoring, for example, for tire wear, the current tread depth of each tire, but we can also do a forecast for the end of life for the component, which is, of course, a really powerful tool, completely software-based for all the after-sales and predictive maintenance solutions in the market. Same for brake wear. And brake wear, for example, where we can predict the current thickness of brake pads, brake discs, and also do an end-of-life forecast. And then I would say, let's go to our last pillar. And Daniel, I know you are expert for this one.
Yeah, last but not least, our additional measurement capability virtual sensor application area deals with the entire world of virtualizing additional testing equipment. So this is basically the holy grail for the R&D engineer. Because what we are doing here is, as I said, we are virtualizing testing equipment like the one you can see on the right-hand side here in this picture. Which is usually used in R&D scenarios, for example, for the dimensioning of specific components like chassis, suspension systems, and so on and so on. But the idea here is to empower every series production vehicle to measure these kind of physical quantities in order to get a more far-reaching idea on how are my vehicles actually doing. What's the actual customer profile? Where can I enhance the dimensioning of my components, and so on and so on. If you don't know what this device is actually doing, it's called a so-called V-force transducer, then you definitely have to join our next webinar where we are showcasing a specific use case with a customer where we virtualize these kind of equipment and give you a entire idea of the behindings, the background behind the project, the benefits, and so on and so on. And basically that's it already for today for our presentation. So thank you very much for listening. Just a small point of advertisement. If these topics are of interest for you, and you might be also attending the Automotive Testing Expo, which is going to happen in Stuttgart in the first week of June, feel free to come to our booth to get a live demo of our virtual sensor platform, which we will be showcasing in the third episode of this webinar, but also obviously to discuss the entire portfolio of our virtual sensors or even new application areas. We would love to have you there. And yeah, I think we can kick off the Q&A session then. Thank you very much.
Thank you very much. Looking forward to your questions. So I think we have one hand raised, but please use the Q&A chat tool in the meeting to ask the questions. Still have 10 minutes left, so no hurry.
How do we feel about opening up the mic for them and just letting them ask the question?
Hey, we have the first question.
Wendy and I have Fabian.
Hello.
Hi,
Hello,
Wendy.
can you hear me? This is Wendy. Yeah.
Go ahead, Wendy.
Oh, so thank you. Yeah, I have a question. So just a quick review, the introduction. So what will be the price range if I want to get one software and the hardware? What will be the average price range? I want to know it. Yeah.
Thank you for the question. Daniel, would you like to, or Stefan?
Stefan?
Okay, I can go for it. So regarding price range, if I got the question right, so what is the price range also for virtual sensors? This, of course, highly depends on the use case, and it highly depends also on the deployment method, I would say. Because as you can imagine, if we're talking about vehicle engineering, V-force transducers, which are very costly from a hardware point of view, we have a totally different price point than when talking about a vehicle mass or a tire wear, etc. So it really depends, I have to say, on this point. The normal engineering answer normally. It depends on use case and also on deployment option if we are talking about the cloud deployment or an in-vehicle deployment, I would call.
I think we have another question. Runkel, I know that you've raised your hand, but would highly encourage you to please use the chat function or the Q&A function. We have some questions that we've published. So there's a question from a guest. What are the limits of the application for the application of virtual sensors?
Yeah, I think I can also take this one if you want, Daniel, because I think it's related to my previous answer. What are the limits for the application? I would say from our point of view, I would say limit is like regarding 2 points. I would say, of course, the data and the compute, I would call it. So first one, of course, whenever you have data in place, we come in the game, I would say. So of course, it depends on the use case. But for example, for a V-force transducer, we need for sure hardware reference target data to train our machine learning model for this one. So I would say it's about which data do you have, in which frequency, maybe also for which hardware sensors. And this would be number one, I would call it. So it really the data. If we have this one and a tick mark on this one, of course, it's all about compute. Where do we want to compute it? Do we have the power and the computing power, for example, in the vehicle to let the virtual sensor directly run in the vehicle? If not, or maybe also depending on use case, it's also possible to let it run in the cloud. Do we have the cloud in place? Of course we have. So it really depends. And if both things, I would say, are in place, there are no really limitations for virtual sensors, I would say.
There's another question from Anne. Hi, Anne, thank you for your question. Yes, we will be sharing the slides and the recording of the webinar with all the attendees and participants that registered for the webinar. I hope that answers your question. We then have a question that is already answered by Matthias from our team. Is there a vehicle on road where I can experience a software solution? He's given the answer as yes. I know that there are some videos of us doing this in the past. Would you like to take this? Or we'd be good to go on this one. We have a couple of other questions as well.
I think we can stick to the yes.
Yeah,
Okay.
I think we can stick to the yes. Yeah, and more to come, obviously. And as I'm speaking already, there's another question. Can I do custom sensor for my specific use case easily? That's a very good question. So you might think that there's just one model for one use case, let's say tire wear. But this is not the case. We can specify the model on the one hand side to the input signals. So Stefan already referenced to this, that for each use case, obviously, we need the right data. However, we can align on the data situation of the customer all the time. So let's say the ground dynamic, the basic dynamics of the reconstruction of the signal is the prior one, then we can align on this. If we are talking about vForce transducer virtualization, if we have to have a good idea on the peaks that these devices basically capture, then we can focus more on this one. We can also, this is also a case-by-case situation, but if there's a signal missing that we would need mandatory, there might be another signal where that we can use as addition, so to say, or as replacement for a signal. So the short answer is also yes, the virtual sensors can be customized to a specific situation. And most of the time have to, because of the vehicle dynamics and especially plausibility of the results, that a customization is always recommended from our side, I would say.
Thanks, Daniel. There's another question. How do you detect anomalies in tire pressure when only one sensor is used? Stefan or Daniel, whoever wants to go for this. I think Stefan goes.
Okay, yeah, I can go for this one. Of course, it's also a little bit of our secret sauce, I would say. So, of course, I will not tell exactly in detail, but you can. Normally, we are using several signals also coming out of the CAN, and we also have like experience when these signals also have some indication when an anomaly is there. And the combination, I would say, of these CAN signals and the interpretation from the model, then of course will also have like this detection of anomalies, I would say. Hopefully this answered your questions in general. But happy to talk about more in detail, also one-on-one on this. Then I think we have another question. What are the accuracies reached by the virtual sensor with respect to reference sensors, e.g. for WFT, pressure, temperature, tire wear? Daniel, you want to answer this one?
Yeah, I can answer this one as well. Basically, it depends on which performance metric you're talking about. So usually we're using things like RMSE, things like duty value, and so on and so on. Here, if we are talking about the vForce transducer, this is something that I have stored somewhere in my mind, but I think we talking about here about 0.x kilonewton. So roughly, let's say 250 Newton, something around this. For the tire wear thing, this is something where we reached accuracies far below 1 millimeter. For the vehicle mass, we have already evaluated several use case applications for various vehicle types, where we are talking about a, I would say, double-digit kilogram range. It always depends on the data situation. That's just the way it goes. The better data we have, the better the virtual sensor can perform. It's a case-by-case thing. We also did a project for because I see the temperature topic here, for tire and brake temperature, where we also reached about 5% deviation from the actual hardware reference. So this is basically, I would say, the baseline is always to get a roughly 5% deviation from our virtual sensors. Most of the time, we are extremely overperforming, I would say, so reaching far below 5%. I hope this answers the question.
I think there's another one. On which components did you already tested this technology for predictive maintenance purpose?
For a couple, I would say. So basically, the whole idea started on the evaluation of the stress of an entire gearbox system. So what we did there is we basically virtualized strain gauges. This is something that we're doing quite for some time now, not only for gearboxes, but we did it for the tie rod, the drive shaft, and many damper forces, for example. We did all that kind of wear components for brake systems. Stefan mentioned the discs and the pads, tires. We did a project where we evaluated a specific force happening on a chassis location. The application area is wide-ranging, I would say.
I also mentioned that you will get back to them with more details and for the specific questions that I've asked, because this is probably a larger forum to address each thing with more specific details. Siddharth, is it possible for you to just drop the question in the Q&A? We want to keep it really short. We just have a minute. We want to also keep it super precise. So we want to end on time. We started on time. Any questions that we can address in an email, one-to-one conversation, really happy to take it forward even after the event. But if there's a question that you can just drop in the Q&A, we'd be happy to just take it right away. Thanks, Siddharth.
Perfect. Then really looking forward to all the questions, and so that we are finished on time. The only thing I have to say is see you next time for webinar number 2, 13th of June. And we are happy to welcome you all for how to virtualize wheel force transducers with virtual centers. Thank you, everyone.
Thank you, everyone.